Hey everyone, this is Tony Lyons and welcome to the CG Compositing Series. In this first video, we're going to be going over some basic fundamentals and getting familiar with some terms and concepts of CG compositing. So it's going to get a lot more complicated in other videos, so don't worry. Feel free to skip ahead if this is too basic for you. But I would like all of us to be on the same page when we are talking about renders and some of the terminology that we often use when we're using CG compositing. So let's just jump right into this. What is a CG multipass render? A CG render with multiple extra layers or passes that are to be used to recreate the beauty render, which is the final image, and to aid in further manipulation while compositing. And why do we need it? It's a good question. So renders are expensive, and changes by the client are often necessary. They can take too long to make tweaks and hit notes if you have to keep re-rendering the image. The rendering software takes a long time to render the images, and if you can make a quick change, it's better to do it in comp. Sometimes it's faster to find the look that you're going for in comp rather than waiting for render results. So if you're trying to experiment and find different lighting and colors, sometimes it's easier to find the result that you're looking for in comp and then do a round trip back to CG once you have made the changes in comp. It's much faster to make the changes and see the results in comp, and then you can go back. Some effects are better achieved in comp, and they need additional passes to help achieve those effects in compositing. So if we're talking about depth of field that you might want to do a rack focus or something, that can be time consuming to do in CG, and sometimes it's much faster and more creative to achieve that result in compositing. Also, for example, if you were to comp, say, a 2D flame, 2D fire into a CG shot for more realism. Maybe, for example, you'd want to relight the CG scene in post in 2D once you place the card with the fire around. So those types of effects we would want to do in compositing, and then we'd need some additional passes to help us with relighting, for example. So let's take a look at this beautiful CG scene that we have here of a fruit bowl, courtesy of Chase Bickle. Thank you for the render. And let's say we have this fruit bowl render here, and we have a client that says, you know what, instead of that lime, let's make it a lemon. We say, okay, no problem. So we can change it into a lemon. Then let's say the client says, you know what, the fruit feels too shiny. Not a problem. We can lower the spec of the fruit. Here we go. And you see that light in the back on the table. The client would like to change it from this cyan color to more yellow. Not a problem, we can do that as well. Boom. Then we have a warm yellow light in the background. And maybe the client says, actually, the lighting sucks. Let's make it more moody. And we say, okay, no problem. So all of these are examples of things that a client might ask you to do. Now, all of these changes were done in compositing. There was no re-rendering of the image. They came from one beauty render with lots of passes, and I was able to achieve all of these notes that the client had given us using the passes that we had in our multi-pass render. And that's what the series is going to be about. It's going to be about how to use these passes to achieve these results, and focusing on why we need a multi-pass render in the first place, which is to achieve these difficult notes without having to go back into the 3D software and re-rendering the image. Here are some useful terms and definitions that I will be using in this series. They are commonly used in the industry, but sometimes they can be confusing or interchangeable, so I'll try to define them for us to help while discussing CG compositing. So a render is the output image or final result of the export calculation from CG software. It is our final image that we're trying to use. A renderer, or render engine, is just the algorithm that is used to produce the render, or the software that is being used to produce the render. Render passes is a general term for additional layers exported by the CG renderer, meant to be used alongside the main render. These might come contained within a multipass EXR, or be rendered as separate images. Let's dive into the Nuke script that we're going to be using. This is going to apply pretty much to all of the Nuke scripts that I'm going to be using in this series, but at the very top, you're going to be able to find a SourceImages backdrop, and that is where you're going to find all the reads inputs that you can relink and follow along. I'll be providing you with either the downloads to, for example, these Fruitbowls, or the links to the images that you can download for yourself to follow along at home. So all of the read nodes of the script are going to be located in one SourceImages backdrop, and we're going to be populating the rest of the script using Adrian Pueyo's stamps. If you don't know stamps already, I highly recommend it. It's a hidden input system that allows you to take the read nodes and keep them in one place and just sort of copy paste, and they auto reconnect for you. And you can look at them throughout the script. I'm using Stamps 1.1. It's a fairly new release, and one of the major features is that I can have a postage stamp. So I can actually see from a distance what I am looking at. I just click Alt-P for the postage stamp there. So that's a pretty cool feature, and it's going to allow us to not populate the whole script with a bunch of read nodes that are duplicates, and so we can just be nice and clean with our scripts. If you do want the stamps to function exactly the way that I'm using them, where they reconnect, and if they disconnect, for example, they turn red, and you can reconnect. So all these nice features and buttons from the stamps, if you want them to do the same on your computer, you will have to go install stamps. It's free, and it's very easy to install. Just follow the install instructions from Adrian, and it should work for you. But even if you don't install it, these are just going to be kind of stupid postage stamps, so they're not going to disconnect or anything. You're just not going to be able to copy and paste it while it reconnects. So basically, they'll just be sort of like the default postage stamp, like this, with the input hidden. So none of these buttons will work for you, but if you're just viewing the script for learning purposes, it won't matter. But if you want to play along with the stamps and in the scripts the same way that I am, then go ahead and download and try it out. So if you're new to VFX or compositing or CG rendering, you might be wondering, what are these names at the top here? These are different renderers or render engines that have produced the image. And so you might be asking, why do we have 3 different Fruitbowls? And we will get into that soon, but not every render engine is the same. So let's talk about it. Different types of renderers. So quick caveat before we start this, I am not a lighter, so this is just the best of my knowledge of the renderers that are in the industry today, which is sometime in late 2021. Of course, this changes all the time, and there might be some better, some worse, but for the most part, here's just a few of really common renderers that you're going to find in the VFX industry. So in no particular order here, we have Arnold, Redshift, Octane, V-Ray, Cycles and Eevee, Mantra, Renderman, and Maxwell. Now, before anybody kills me here, I know there's a ton of other renderers out there. I did do a lot of research, and I found some great websites that go into a lot more detail about many other renderers in the industry. So here's a website from Tool Farm where they compare different types of renderers, and they have a really nice list over here. You got Keyshot, RenderZone, URender, all this kind of stuff out there. There's another website here, 10 Best Rendering Software by renderpool.net. Here they mention LuxCore Renderer, Radeon, Fruitbowl. So a lot of these I'm going to completely admit I've never heard of, and so I'm just choosing some of the ones that I have definitely seen throughout my career in the industry. So it's not to rag on any of these other renderers, it's just that I want to fit the ones that I've heard of into the list, and I can't mention everyone under the sun. But I can provide you with these links, so if you want to do some light reading, and if you're more curious about other renderers, then feel free to do some cool deep dives into all the options that are available for you. Okay, now that all the lighters have put their pitchforks down, let's go back to the slides. Some of these renderers actually come with different applications by default, which make them even more popular than some of the other ones. So you can see here, you can almost couple some of them together. And Maya, for example, comes with Arnold, and Cinema 4D comes with Redshift. Blender has Cycles and Eevee, and Mantra is Houdini's renderer. So Octane, V-Ray, RenderMan, Maxwell, and some other renderers, those are third-party plugins. What does that mean? It means you can buy them as a plugin, and for example, you could buy Octane for Maya, or you could buy V-Ray for Cinema 4D or something. So they don't belong to any particular application. And also, it does not mean that Arnold is only exclusive to Maya. I'm just saying that it comes default with the application, so that's why it tends to be used quite a lot in the industry. So I do know for a fact that Arnold, you can have it as a plugin for Cinema 4D, for example. Same with Octane for Cinema 4D. Once again, I am not a lighting artist, so take this with a grain of salt, but from these renders, I would say that we can narrow it down even a little bit further to renderers that are probably the most common today in 2021. And this is just, I guess, my pick. It's what I've seen the most and what I think most people are probably using. I could be wrong, so yeah, please correct me if I am wrong in the comments. But yeah, I would say that Arnold, Redshift, Octane, V-Ray, and Blender with Cycles and Eevee are probably the most commonly used. I will admit that Blender is more kind of an independent film because it is free. I know a lot of people will be using it because it is free, but you most likely won't see that in production because of the implications of using free software. I think maybe that will change in the future, but certainly a lot of independent filmmakers are using Blender, and people that are just experimenting for the first time with 3D and getting really into it. So that is why I've included it on this list. I'm sure a lot of people do use it. But yeah, for sure you do see V-Ray, Arnold, Redshift, and Octane in production on a regular basis. Of these renders, which ones are we going to be using in this series? We are going to be using Arnold, Redshift, and Octane. Those are going to be the three Fruitbowl renders that we have managed to create for you guys with the full range of AOVs and passes that you could possibly think of. And the main reason is because we were setting up the scene in Cinema 4D, and these three render engines were able to be used with Cinema 4D. And so we bought some plugins for them, and we rendered one Fruitbowl for each render. So trying to get the most bang for our buck, and hopefully it covers a wide range of possibilities of renders that are out there. I just wanted to briefly take a moment to show you the inspiration that I actually got for this Fruitbowl render, which was on YouTube. I saw this video of somebody comparing renders to each other, and it was of this Fruitbowl, and it's using Arnold and Cycles, and you can see it's kind of going back and forth comparing the two. And I was just following the rabbit hole of where this came from, and it did come from an artist named Oliver Harries from Hamburg, Germany, and obviously very, very talented artist. But I did notice right here that there were some free photogrammetry models. So this is, I'm going to provide this website to you in case you're curious of downloading it and trying to recreate the scene. I will definitely provide the scene to you. And if you want to download the assets of the scene, they came from Oliver Harry's website here. So good on him for doing this photogrammetry of these awesome fruits. They look really, really super good. And a friend of mine, Chase Bickle, who is also a 3D artist and designer, set up the Cinema 4D scene and was kind enough to make 3 renders, Redshift, Arnold, and Octane for us from Cinema 4D using Oliver's models there. So thank you very much, Chase. We all really appreciate it, and I'm super happy that we're able to get these renders out for everybody. Now, the main difference between these renders and a typical one that you might search for on Google is they're very big. They have a lot of passes. So they're going to be around 500 megabytes each. So that is very typical in big productions, that you get a lot of passes. So that's what I wanted to give you guys, a realistic render for what we use in production. At the top of the script, you're going to see 5 assets here. We have 3 Fruitbowl renders from Redshift, Arnold, and Octane. You can see that they're all a little bit different. That's just the nature of the different render engines and the materials that remade the scene, so that's not a problem. And we have a V-Ray render, which I did grab from a Chaos Group website. Chaos Group made a nice blog post about how to use Cryptomats for V-Ray, and inside of this blog post, which is pretty cool, they have a download example scene there, and if you download that, you'll find this image that I am using inside my script. And the last example is a RenderMan file, and I did get this from the Foundry in their toolsets menu actually. Installed in everyone's Nuke in the toolsets over here, we have under 2D, we have the CG folder here with a TB CG Beauty. If you click on that, you're going to get a lot of AOV, multipass comp, rebuilds and stuff, which is cool. We have Arnold, Cinema 4D, Modo, RenderMan, and V-Ray. But down at the bottom here, it's asking you to download the toolset files by either going to this link in the browser, or if you just double click on this examples node and you click on the download toolset examples, it's going to open up a browser and going to download like a 2 gigabyte zip file containing a bunch of images that go with basically the rest of their little example files here. I'll be providing the first 3 Fruitbowl renders for you guys. They're about 500 megabytes each with all the passes. And the last 2 files, you can download them on your own. I don't think I can redistribute them. So if you want to follow along with these images of the V-Ray and RenderMan examples, then you can download them yourself with those links. Let's look at some different ways to view render passes in Nuke. So I'm going to look at a few different ways. It might seem a little bit basic, but yeah, let's just go through them for anybody who doesn't quite know how to do this yet. So here we have the render. I'm using the stamp there. So this is the Redshift Fruitbowl. And the first way, and probably the easiest way, honestly, to get an overview is the layer contact sheet node. So if I go here and type in layer contact sheet, if we plug it in, it is actually going to give us a grid of all the layers that are contained inside of whatever you're viewing. So it's displaying all the layers, and there is a little checkbox here, show layer names. I have mine just to show up by default, but just remember that you'll need to click that to see these layers. So you can see here all the layers that we have for this Redshift render. Now, one thing to mention is that these text actually is just a Nuke GUI. So if I turn my overlay on and off, it goes off. So what that means is that you can't actually render this out. It doesn't actually render the text out. So if you're ever trying to present this in this nice contact sheet, it's just for you to view inside of the viewer here. So just something to remember. But it is a great way to get an overview of all the layers and to find what you're looking for. The second way that I would recommend to view layers would be just in the viewer. So if I wanted to see a nice list of all the layers that this render contains, if I go to the viewer up here in next to RGBA, if I click that, it's actually going to give us a nice list of all of the passes that we have available for us. I did click on the other layers. Those are not part of this. So it's basically everything from alpha all the way down before other layers just below this. So all the way from AO to UV. So it's a nice way to get just a straight list. So the layer contact sheet is a bit more visual, and you can find things very easily. But if you just want to see a nice alphabetized list, then you can go click on the viewer. And of course, if you clicked on any of these, the viewer is going to show that layer to you. Just remember to set it back to RGBA. I always forget and then think my Nuke is broken, so never forget to set that back to RGBA when you're done looking at the layer. There's one nifty hotkey actually that comes default in Nuke, which is that you can hit the page up and page down buttons, and that'll actually cycle through the layers in the viewer. So you can see up here it's changing GI raw, ID 1, 2, 3. So I'm just clicking page down and it's going through. Page up is going to go to the one before. So it's just a quick way to search what you're looking for, and it's really handy. The third way, and probably one of my favorite ways to view what layers are currently in the area of the script that you're looking at, is with a shuffle node. So if you bring up a shuffle node, and yes, I'm going to use the old one, and I can tell you why in just a second. I do like the old one, even though there's a new beautiful shuffle that the Foundry has graced us with. But there is actually kind of an important reason why I still like to use the old one. So the shuffle by itself is not going to show us the layers. These are just the default layers in Nuke. So the reason it showed me all this is because I hovered over the other layers, and other layers shows you every single pass or layer that is in the entire script, because you're kind of choosing from the library of every layer that exists in the script. So that's why it's a huge giant list. But that's irrelevant to what you're looking at. So you can see the list is empty here. It's got RGB, RGBA, and alpha. So just the basic ones there. So, but as soon as I plug in the shuffle, if I go back to that and I click on the in one there, now suddenly it looks just like the viewer that we were looking with. So we can quickly, if I'm viewing the shuffle, we can quickly see. See, I forgot to put it back to RGBA in my viewer. See, I knew I was gonna mess that up. So you can quickly see what you are looking at if you just preview the layer. So if you wanted to see what the layer is, you can quickly just jump to it. And the reason I like this so much is just because I really dislike setting my viewer to something other than RGBA, from the reason that I just gave, where I forget all the time. Possibly bad habits on my part. However, I do think it's just really quick to see the list. Now, it's not as visual as the layer contact sheet, obviously, but if you know what you're looking for, like if I'm looking for the position pass, then I can go there and find it. So if I have a smaller scene example here, I just have a few cubes with a checkerboard in Nuke, but I just wanted a smaller script with less layers in it. But I just wanted to demonstrate that, in fact, the list reflects what it is plugged into. So you see here, you see depth, motion, forward, and if I just had a simple maybe checkerboard, then depending on what it is plugged into, it's just going to show me more or less layers. So here, since the checkerboard is just RGBA, there's no more layers to show. So this could be a quick way to see if there are many layers in the thing that you're looking at. If you had a much bigger script, for example, than this one, if you took a shuffle, just plugged it in, and you're kind of just checking in various parts of your Nuke script that it's probably going to be much bigger. But you'll see if I maybe switch this to all channels, then you see if I go back to the shuffle, you'll see it there. Of course, you can do this in the viewer too. It's just depending on if you what you like to do, and you can do it with a layer contact sheet as well. But I tend to like to just see a quick list of things. So I really like the functionality of the viewer, where you can hit page up and page down to skip to different passes that you're looking at. And I will definitely set this back to RGBA now. So I decided to make a little Python script that cycles the layers, just like the viewer does. So it has the same functionality. So you can download this. I did upload it to Nukepedia. It's called Shuffle Cycle Layers, and the link is right here in this backdrop. So if you just click on your shuffle, you have to have the shuffle selected, and if you just hit page up and page down, it's going to go through all of the layers. And once it gets to the bottom of the list, you remember that it had the bottom of the list before the other layers there. So once it gets to the bottom, it just cycles right back up to the top, right back to RGBA. So it skips right over RGB because, you know, why would you want to look at RGB and RGBA? Just RGBA is fine. So it just cycles through. So it starts from the list at the top again and goes down. It is nice if you're already used to the viewer page up and page down. But for me, I think personally, I like minus and plus symbols next to the backspace, or I guess it's the dash and the equals. So that is something that you could hotkey it to as well, if that's more comfortable for you. One of the reasons that I'm not actually using the new shuffle node, even though, you know, I probably just haven't gotten used to it yet, but I do miss the functionality where the shuffle would display only the layers that were in the thing that it was plugged into. And unless I'm mistaken, I could be wrong, but if I go to this layer list, it does look like it's displaying every layer in the entire script, which I don't quite understand because it's set to NB, so I don't know why it would give me the options for every layer in the script. I mean, I've had something like 250 layers in a giant Nuke script before, so I could imagine if this list was, you know, double or triple this amount, it just doesn't seem as useful as picking layers that already exist. For example, if we go back to the old shuffle, it's only displaying these select layers that are for sure in the beauty that I'm looking at right here. So I'm not sure if there's something I'm doing wrong. I tried going to this side and I don't know, I just I'm not quite used to it yet, and so that's one of the reasons actually I quite like using this old shuffle. I mean, I'm already used to it, so I guess I'm starting to become a dinosaur. It happens to the best of us, but yeah, if you find a workaround or you don't care about that, then you know, feel free to use the new one. If you would like to exclusively just use the old shuffle, I did find a useful just a line of code here in Python that you can add to your menu.py. And just a useful tip for you, if you ever want to get the old shuffle node really quickly, in the node graph, if you click X, it'll bring up this command prompt. And if you type in shuffle with a capital S and click OK, it's going to bring in the old shuffle node. And the new shuffle node is actually just called shuffle 2. So if you click OK, that brings in the new shuffle node. The last way I wanted to show you how to view layers is with a nifty little Python command called split layers. Now this comes in a few different forms. I actually found like 3 different versions of this on Nukepedia. So we have split layers, shuffle channels, and multi-channel split version 3. So you can click on those links and download whichever one that you want. But they kind of do the same thing, which is that it runs a script that is going to take whatever you're looking at, whatever you have selected, and it's going to break out all of the layers. So here I just have it in the menu. It's called the split channels. And if I do that, it's just going to spit out all of the layers in their own shuffle node. And I can click a dot here to make it a little bit nicer. Now, it looks a bit crazy, but what's cool is that you can just go, 1, 2, compare them. You can kind of group them up. And this can be a really easy way for you to get started on some template or something that you're going to start working on. So I think all of these scripts basically do this same thing. So this is just a kind of a node graph way to view a more so each of these is its own thing, its own layer. So you can view them all. Let's talk about the difference between layers and channels in Nuke. And this is what I understand as layers and channels, and maybe it's different per artist or per studio about the vocabulary of these two things. But let's take a look at what it means in a Nuke context. So channels are the individual pieces that make up a layer. It's also called a channel set. And the most common example, of course, is red, green, blue, and alpha channels make up the RGBA layer. So a layer must contain at least one channel, but often has multiple channels. Nuke prefers layers to have a maximum of 4 channels per layer, and any more than that, and it has a difficulty displaying them in the GUI interface. So not that it will error out or anything, but it's a little bit maybe buggy on how you can view those channels when they're inside the layer. I know this is a really basic example, but just to illustrate the point. So this color wheel here has RGBA channels, and we can see them in the viewer by clicking RG and B, so red, green, and blue, and that's going to show us the component of this color wheel that makes it up, so red, green, blue, and alpha channel, which is just a solid circle here. So Nuke is displaying the layer RGBA, and it's displaying the individual channels here, red, green, blue, and alpha, that make up the layer RGBA. Let's just say that I want to add more than 4 channels into a layer, just to see what happens. So here I've added red, green, blue, and alpha into the color wheel layer. And I've also added 4 more channels into the color wheel layer, Tony, Steve, Bruce, and Thor. So if I wanted to see those channels in the viewer, I would have to go over to the color wheel layer. And as usual, if you would press RGBA, it's going to show you the first 4, which would be color wheel red, green, blue, and alpha. But if I wanted to see the other channels, it starts to get a little bit more difficult, where I can see if I click up here on the second menu, you'll see all of the layers. So I could, for example, view color wheel Steve here. And in order to see the Steve channel, I have to press A and view this alpha here. And that's going to display what you see here, color wheel Bruce, color wheel Thor. So it starts to get a little more difficult to see these extra channels in the layer color wheel. Also, there's a little bit of funkiness in the GUI. For example, if I'm using a shuffle node and I bring the dropdown down to this layer where I have more than 4 channels in it, you can see that it's replaced the RGBA at the top here of the shuffle with Tony, Steve, Bruce, and Thor. So there's a little bit of a kind of funkiness that goes on in some of the nodes when it finds a layer with more than 4 channels in it. So it's just something to be aware of. An individual channel in Nuke is written as layername.channelname to let you know what layer the channel belongs to. Depth.z, for example, is the depth layer, which is the layer name, and z is the channel name. Whenever there is only one channel, this displays in the viewer as the red channel, since it's the first channel visible in RGBA. There are many cases where somebody will just refer to the depth channel, where they're actually referring to the layer depth, but since it only has one channel, they're basically talking about the same thing. So that is where the jargon and the terminology gets a little bit mixed up, but usually it would just mean that depth channel only has one channel, and so you can just say depth channel and it works out the same way as depth layer. Just for demonstration purposes, I will show you a very simple 3D scene here in Nuke, and we're going to look at the depth channel that is in the scanline render. It comes by default. And if you go up here, you'll see our layer, which is depth, and it is displaying red. It's displaying red because there's only one channel, and so it only takes up the red channel there. You can see in the list we have red, green, blue, alpha, and then depth.z. So there is no more channels to depth, so it's just one channel, and it takes up the red in the viewer. Now, if you shuffle out the depth, I'll put this back to RGBA, it's going to display as white, which can be deceiving, but you can see if we go to the shuffle that the red, green, and blue alpha outputs are all just pointing to the one channel. In fact, there's no more than Z throughout the depth there, so they're all just defaulting to that. So in a way, it's very similar to how if you were to take a color wheel and you just shuffled everything to red, that you'd only see, the red channel as white. So that's what's going on here when we view, or when we shuffle out rather, the depth channel. So even though it's displaying as white, as we mentioned when we view it in the viewer, it is just one channel, so it is red. Some nodes in Nuke are dealing with layers and channels differently, or they're dealing with one versus the other. And the most common example that I could give is with a shuffle node, the drop-down list in shuffle node is displaying the layer names and just the layer names. So these are all of the layers that are in my Redshift Beauty render here. So these are just displaying all the layers. A copy node, though, for example, is going to display a list of all of the channels, the individual channels. So here you can see my list is much bigger, and it is displaying all the RGBA channels for the layers. You can see ID1 red, ID1 green, ID1 blue, ID1 alpha, etc. So that's why the list is much bigger, because it's showing the individual pieces of the channel. So these two nodes are dealing with different things. So the copy is going on a per channel basis, whereas the shuffle is dealing a little bit more with layers, although the grid is set out to adjust the channels. So the drop-down lists are displaying the layer names, and then the grid items are the channels. So just a couple more examples with a blur node. So the blur node, even though it says channels up here, it's actually displaying the list of layers. So if I went over to blur this reflections layer, of course I can check on the individual channels, but it's actually going to blur the layer reflections. So if I were to view reflections, you can see that it's blurring that whole layer at once. And basically every node with a mask input, a mask is only looking for one channel. That's what is needed to define, what happens where. So that is why it's going to be a channels list. So you can only select an individual channel, for example. The first 4 channels of a layer are mapped to and will display as red, green, blue, and alpha in the viewer, regardless of the actual name of the layer. Any more than 4 channels in a layer, and Nuke has a hard time displaying them, as we've just demonstrated. A motion pass, for example, is describing motion in X and Y directions, left, right, and up and down. So only 2 channels are needed in the layer, and they will display as red and green. Usually those channels can be called U and V. A position pass, for example, is usually describing XYZ 3D coordinates, and sometimes the channels are actually named X, Y, and Z, so position X, position Y, and position Z. Since X, Y, Z are taking up the first 3 channels in this layer, they will display as red, green, and blue. So going back to my basic 3D scene here, I have shuffled out the motion channel, and on the scanline renderer, the motion vector channel is set to forward. I do think it's actually set to forward by default on pretty much everybody's Nuke. Let me double check that. Yes. So it's set to forward. Now, forward and backwards, if you've seen it before, is they're in Nuke by default. So you get forward U and forward V, and backwards U and backwards V. Those are motion channels, so they're meant to be used as a type of motion channel. So that's why they're default as the motion vectors in the scanline render. I've also output the output vector surface point, so the position pass, as position XYZ, if you can see there. So when I shuffle out the forward, first of all, you can see that there's only 2 channels here, U and V, and it's only going to display a red and green image because there is no blue channel. So here's red and green, so it's got information in it that we can use to apply motion blur, for example, but the blue channel will be empty because essentially a third channel does not exist. So it's just U and V, or in the viewer it would be displayed as red and green. The position pass is this nice colorful image here, and this is just if you see my my cursor here in the bottom section here, you'll see these numbers that are telling you the exact 3D coordinate space of the position. So the thing to know is that even if I go to the position pass up here, you can see they're named XYZ, but it is displaying the position pass just with red, green, and blue. So red being X, green being Y, and blue being Z, so XYZ. So there you have it. It's just a quick demonstration that the channel names actually don't matter as much as the amount of channels and the sort of the order that the channels are in. So like I was saying before, Nuke prefers 4 channels or a maximum of 4 channels, and the first 4 channels will just be displayed in the viewer as red, green, and blue in alpha, regardless of the name. In the next section of this video, I'm going to be introducing you to AOVs. Let's take a look at what AOVs are. So AOVs stands for arbitrary output variables. Now, what the hell does that fancy word mean? So straight out of the Foundry's website, they give a pretty good definition of it. Arbitrary output variables, AOVs, allow data from the shader or renderer to be output during the render calculations to provide additional options during compositing. This is usually data that is being calculated as part of the beauty pass, so it comes with very little extra processing costs. They can be considered checkpoints or steps in the rendering process. The render engine splits up many calculations while making the final image, the beauty render, and is exporting these smaller steps out to disk so that we can combine them and then manipulate them in comp. The important thing to take away is that the renderer takes these pieces, these AOVs, and combines them together to form the final beauty render. And we are essentially trying to recreate this process with our CG Rebuld, while retaining control over the individual pieces. One of the best things about AOVs is we get them for free, since the renderer was going to calculate them anyways. AOVs can sometimes just be a catch-all term for all the layers and passes that you need to render out. For example, what AOVs are you exporting is a very common question, and many 3D applications even use the term AOVs to just define any render pass, even though some of them do require some extra work to get, like IDs or custom passes. So AOVs and render passes are essentially the same thing. All AOVs are render passes, but perhaps not all render passes are AOVs. So we're going to look at the results of these 3 different types of render engines here: Arnold, Redshift, and Octane. And if I do a layer context sheet on all these, you're going to notice that they're slightly different from each other. They're producing either more or less passes. I guess there were more options for us to check on for as far as AOVs were concerned. And also the namings of them change slightly. And so we're going to briefly talk about the differences between these render engines and render engines in general. What's the difference between the renders and why should I care? So all the renderers are essentially doing the same thing. They're crunching the numbers using different algorithms and coming up with the math needed to produce the final renders. Since all the renders are basically doing the same steps and calculations, you just have to get used to what the renderer is choosing to name these AOVs or lighting passes. All the passes will combine together and add up to the final beauty output. There are certain similarities or patterns between all the renderers. Sometimes in this series we'll be looking at one renderer to explain concepts, but they often translate over to other renderers in some way. So keep an eye out for the patterns described and apply what is being taught to your renderer's output. We're going to be looking at some very basic AOV rebuild equations for the different renderers that we have. You can already see that, for example, the Arnold one has a few more passes. And this is going to be very similar to the AOV rebuilds that you can find by default in your toolsets that comes with every Nuke from the Foundry. But we're going to be making them custom for our renders here. So starting with the Arnold basic AOV rebuild equation, if we zoom in here, we can see that we've shuffled out all of the passes into different shuffles that we need to rebuild the beauty. Some of them are blank because there happened to be nothing rendered into those passes, but they are quite frequently rendered with Arnold renders, so I did leave them in there as they are probably part of the equation if your specular is broken up into different layers like the coat and sheen here. So all of these shuffled out passes are simply being plussed. So all these merges are just plussed. and the end result will be 1-to-1 with the beauty. So if I A/B the beauty, it matches. There may be maybe a 1% difference or something, but it would be very, very subtle if it is a successful rebuild. From left to right, let's go through all the passes that are being added together to rebuild the Arnold render. So we have diffuse direct, diffuse indirect, specular direct, specular indirect, coat, sheen, SSS, transmission, and emission. Now the coat, sheen, SSS, and transmission in this case were empty. Let's do the same on the redshift AOV rebuild. We have diffuse lighting, GI, specular lighting, reflections, SSS, refractions, and emission. In this case, there were no refractions in the scene, so it was empty. And finally, let's take a look at the Octane AOV rebuild and what passes we have. We have diffuse direct, diffuse indirect, reflection direct, reflection indirect, subsurface scattering, refraction, and emitters. And in the Octane case, the subsurface scattering and refraction were empty. So you're seeing some very similar names in there. So we're going to talk more about each of these in a future video, but I just wanted to give you the basic AOV rebuilds that you would need. This is kind of the bare minimums that you would need to rebuild these successfully. And while the renderers have different names for things, I think you noticed some patterns there. A lot of diffuse, speculars, and SSS or subsurface scattering. So even though all of these things are naming them slightly different, they're all sort of rendering very similar types of passes that we use to combine and make up the final beauty render. And just for those who find it more useful for it to be written out, I have listed, I suppose you could say, the equation for the different renderers and the different naming conventions that they're using. So you have Arnold AOVs, and these are all the passes that equal the beauty, and then the redshift one and the Octane one. Now, I did grab the Arnold and the redshift AOV equation from the documentation that comes with Arnold and redshift. The Octane one was slightly harder to find. I guess there wasn't much documentation for it, but all I did was I just wrote the equation from what I had gathered from just adding the passes together myself. So the first two, Arnold and redshift, do have sources, and I'll list them in the description. And I guess the Octane one, you'll just have to take my word for it, because that is what combined together to equal the beauty. And this is where I'm going to leave the video for now. In the next video, we're going to talk about the different types of AOVs and how we break them into different categories and going through each type of AOV and what they're doing and understanding them a little bit better. So I hope to see you in the next video. Thanks.